Vectors u and v are called orthogonal if the angle between them is 90 degrees. I love this word, orthogonal. Perpendicular insinuates that you've got two segments, two lines, a ray and a line, a ray and a segment. You've got two lines that actually intersect. Remember, vectors don't have to intersect. So, because location doesn't matter. So these two vectors right here, one is over here, one is way over there. Those two vectors would be considered orthogonal. And the reason being is because when I do bring them together, I can clearly see the angle between them is 90 degrees. So when you have an angle between two vectors that is 90 degrees, we use that really cool word and say that the vectors are orthogonal. Love that word, orthogonal. Now, vectors are parallel. Vectors are parallel if the angle between them is 0 degrees or 180 degrees. Now, they don't have to, as a matter of fact, I'm going to make this there. Okay, two of these angles have an angle between them that is 0 degrees. Going the same direction, the angle between those two vectors will be 0 degrees. However, let me make another vector over here. This way I can just use another color. The angle between the two vectors is 180 when they appear parallel, but their direction is completely opposite. So when the angle between is either 0 degrees or 180, we have parallel vectors. So either one of those cases results in parallel vectors. So we're going to determine whether or not our vectors are orthogonal or parallel, or perhaps neither. So here's our first example. We have two vectors, 2, -3, and 6, 4. I like to draw the vectors so I can get an idea when I begin. So I go right 2, and then I'm going to go down 1, 2, 3. So that's vector u. Vector v, we're going to go right 6, 1, 2, 3, 4, 5, 6, and then up 4, 1, 2, 3, 4. These vectors are definitely not going to be parallel because they're not. The angle between them isn't 0 degrees. They're not going in the same direction, and they're not going in the complete opposite direction. But they do appear that they might be orthogonal. So that kind of gives me an idea. They might be orthogonal. Okay, let's put that back where it was. This is how we find out. We're going to determine, so find the angle between the vectors. Okay. If 0 degrees or 180, then parallel. If 90 degrees, then orthogonal. So the cosine of theta is equal to u dot v. So we've got 12 plus -12 over the magnitude. 4 plus 9 is 13. So the square root of 13 times the square root of 36 and 16 is 52. So I've got the cosine of theta is equal to 0 over some number, which is 0. So the inverse cosine of 0 is equal to theta. Hopefully You remember that the cosine of theta equals 0. That means the x value is 0. So we're talking about 90 degrees here. We're talking about 90 degrees. Well, that gives us orthogonal vectors. So theta is equal to 90 degrees. Therefore, orthogonal vectors. And that's really what it comes down to. So I'm going to box this right here because that's going to be really helpful. If you don't have 0 degrees, 180 degrees, 90 degrees, then you're dealing with neither. You're obviously dealing with neither. Let's go ahead and try this one. Matter of fact, I'm going to let you try this one. See if you can tell me if the vectors are orthogonal, parallel, or neither, and let me know what the angle is. If you can let me know what the angle is, that would be fantastic. Then you really know that you've got it. So go ahead and press pause. And when you come back, you're going to get the answer. Okay, welcome back. I got the cosine of theta is equal to 3/4 over the square root of, I got 5 times 5 over 16, which is 25 over 16. So I got 3/4 over the square root of 25 over 16 is 5/4, which is 3/5. So the cosine of theta equals 3/5. Well, that means that theta is equal to the inverse cosine of 3/5, which is approximately 53.130 degrees. This is obviously not 0 degrees or 180 degrees, therefore it's not parallel. 53.13 is not 90 degrees, therefore not orthogonal. I just like saying that word, orthogonal. So we get an answer of neither. Now, you don't need me to tell you that the practice is super important for you to really solidify what we've done here. The math is pretty easy, but it's remembering what you do, when you do it, and what it means so that you can figure out what situation you're dealing with and pull in the right tools to solve the problem.